Considering tonight, the theme of tonight is Can We Talk? Our sixth graders have put together a skit and a few speeches that they are going to share with you guys tonight about how to have those big conversations about issues with our environment and how they feel about it. So here are our sixth graders. Take it away, ladies.
Oh, look, I made the word chicken.
I need an S.
Can I connect these letters to make this word? Yes, you can, but you have to make the word must.
Celeste, you need to make the word must so you can get 5 points.
Meredith, how many points is this word worth?
That one is worth 10 points.
Oh, look, I got the word glacier. Speaking of glaciers, it's so sad how quickly they are melting because of climate change.
Really? Climate change? My friend's mom says it's just a bunch of lies made up by tree-living scientists.
Meredith, surely you don't believe that, do you? Climate change is a very important and serious topic that affects all of our futures.
Guys, it was freezing the other day. Global warming and climate change can't be real.
Oh no, we've got a lot of work to do, girl. Meredith, come with us. We are going to the science lab to enlighten you on global warming and climate change.
Scene 2 in the science lab of education.
Global warming sounds pretty cool. I like it when the weather is hot. I'd be down with summer all year long. Pools, laying out, going to the beach sounds like a dream.
Global warming is much more serious than that. Look what this website says. Climate change, or global warming, is the process of our planet heating up. The Earth has warmed by an average of 1 degree Celsius in the last century.
1 degree? That's not very much. I thought this was a big deal.
That might not sound like much, but it means big things for people and wildlife all around the world. According to this website, unfortunately, rising temperatures doesn't mean that we'll get nicer weather. If only, the changing climate will actually make our weather more extreme and unpredictable.
Oh geez, that is bad. I guess as temperature rise, some areas will get wetter weather and lots of animals and humans could find they won't be able to adapt to their climate changing.
Exactly.
So what causes it to happen?
Look right here. The National Geographic website says that the Earth's climate naturally changes, but humans are really speeding up the process. The burning of fossil fuels and deforestation are two of the largest causes of climate change.
That's crazy. Is there anything I can do about it?
Actually, there are lots of things you can all do to help out. See, small changes in your own home can make a difference too. Try switching to energy-saving light bulbs, walking instead of using the car, turning off electrical items when you're not using them, recycling and reducing your food waste. All these little things can make a difference.
This climate change thing is a really big deal. How did I not know about it before? Thanks so much.
Okay, now our students are actually going to share a little bit more about some things that they're passionate about and some things that they've actually learned about climate change and our environment that means a lot to them. So here we go. Awesome.
My name is Meredith, and one of my biggest concerns about climate change is how many animals it is affecting around the globe. For example, climate change is already affecting wildlife all over the globe. For example, climate change is already affecting wildlife all over the world, but certain species are suffering more than others. Polar bears, whose natural icy habitat is melting in warmer temperatures, are practically at risk. In fact, experts believe that the Arctic sea ice is melting at a fast rate, nearly 9% per decade. Polar bears need sea ice to be able to hunt, raise their young, and as places to rest after long periods of swimming. It's not just polar bears who are in trouble. Apes like orangutans who live in the rainforests of Indonesia are under threat as their habitat is cut down and more droughts caused by bushfires. Also, our precious sea turtles rely on nesting beaches to lay their eggs, many of which are threatened by rising sea levels. Did you know the temperatures of nests determine whether the eggs are male or female? Unfortunately, with temperatures on the rise, this could mean that many more females are born than males, threatening future turtle populations.
My name is Celeste. My heart hurts for the people that are already being affected by climate change. Climate change won't just affect animals. It's already having an impact on people too. Most affected are some of the people who grow the food we eat every day. Farming communities, especially in developing countries, are facing higher temperatures, increased rain, floods, and droughts. For example, I know many of you all like to drink a good cup of coffee, but I'm sure you take for granted just how much work goes into growing the coffee beans that go into your cup of joe. Environmental conditions can affect the flavor and quality, plus it needs a very specific rainfall to grow. Climate change is making rainfall patterns less and less predictable. Often, there will be droughts followed by huge amounts of rain, which makes it hard to grow your precious coffee beans. Imagine how difficult and scary it is for the people that rely on our earth and its climates for their well-being and income. Next time you drink a cup of coffee, think about the people and families that are being affected by our decisions and treatment of this earth.
My name is Anne-Marie. I truly believe that it is our duty as children of God to take care of the one and only home that our Lord gave us. From the words of our Pope, never have we so hurt and mistreated our common home as we have in the last 200 years. We must all change our day-to-day actions to live more sustainably. Reducing greenhouse gases requires honesty, courage, and responsibility. On a larger scale, our leaders must be held to account. Those who will have to suffer the consequences will not forget this failure of conscience and responsibility. I'll leave you with one last quote from Pope Francis. Yet all is not lost. Human beings, while capable of the worst, are also capable of rising above themselves, choosing again what is good, and making a new start.
So our first panelist is Jenny Hubbard Sanchez, who is the State Specialist for Sustainable Programs and the Director of the Center for Environmental Education at Kentucky State University in Florida. Jennifer is going to help us.
Frankfurt. I didn't come all the way from Florida. I would though.
What about Frankfurt?
Did I say Florida?
You said Frankfurt.
Oh dear, sorry.
We're warning, but not that fast.
So Jennifer's going to help us to understand what science has to say to us about our trends with climate, as our young women have already begun to explain. She's going to try and talk to us about how long we have known a lot of these things and how we know that it's a real crisis. And then after Jennifer will be Sister Maria Vesey, who is from the Sisters of Loretto at the Loretto Mother House. Maria is a nurse, a labor and delivery nurse by trade, and she has recently completed 2 terms as the coordinator of the Loretto Mother House. You might have seen her in the Singing Nuns about
Anti-fracking.
the anti-fracking and anti-bluegrass pipeline video and film. You may recognize her from that. And Maria is going to share with us about what our spiritual nature, our religions, our faith have to say to us about the need to face up to climate change. And third will be Dr. Leah Bayens, New Pioneers Vice President and Director of the Berry Farming Program. Sadly, the Berry Farming Program used to be at St. Catherine College, but since then it's reincarnating itself in Henry County, Kentucky. Leah's going to talk with us about what it will take for us to become part of the solution rather than part of the problem of climate change. So as I said, it's going to be a wonderful panel. We welcome our TV audience from Channel 6. We welcome all of you, and we hope for a wonderful experience together. Jenny?
Okay. I'm usually very loud. Can everybody hear me? No? Okay. I will use the microphone. I don't like microphones. Okay. I want to say thank you to Sister Claire and to everyone at New Pioneers for including me and including Kentucky State University in this evening. I do see a lot of familiar faces. A lot of you were in Frankfurt just a couple of months ago. Some of this is going to sound repetitive to those of you who were there, but we're here doing it again, and I'm very thankful for that. I have 600 seconds to teach you about climate science. I was told 10 minutes, but 600 seconds sounds like a lot more. So the title of my presentation is Climate Change, 600 Seconds to Clarify the Complicated. Yes, and I'm hoping that none of you leave here more confused, because it's really not, usually we do this in 6 hours. So how do I explain climate change? We do it the Mary Poppins way. We start at the very beginning because it's the best place to start. And we're going to start by differentiating between weather and climate. A lot of folks can't define what's weather and what is climate. So climate, it's our day-to-day, right? Right now, today, it was pretty chilly in the morning. I know the roofs where I live were frozen this morning. There was frost. But by this afternoon, it was pretty warm. It was sunny. It was beautiful. That's our day-to-day. Weather tells me what I'm going to wear. Climate tells me what I should buy. So I know in spring, if I see a cute sweater on sale, I may buy it for fall because I know the typical climate in my region, right? Climate is personality, weather is mood. We all have sort of this ingrained personality, who we are, but sometimes we may lose it. Mood can swing. So think of climate and weather in those terms. Weather versus climate. Climate is the average of weather over space and time. Weather are the immediate atmospheric conditions. So scientists used to take 30-year periods, average those out, and say, this is the typical climate in a region at a certain time or in a certain season. And for those of you feverishly taking notes, I also printed out copies of this, so you can take copies of this with you if you would like. Long term, again, 30-year average. Today it's a lot harder for scientists to do a 30-year average because, as you all know, a lot of our averages are quite out of whack. It's really hard to say 30 years ago the typical climate is what we're experiencing, especially in the last 10, 15 years. Weather is the short term. Climate, according to NASA, is what you expect, and weather is what you get. So defining climate change, and I have to hand it to the young ladies that did their skit because really they defined a lot of this for me, so I can probably just go home. You did it in like 5 minutes, so I'm really proud of you all. How to define climate change. It refers to any significant change in the measures of climate for an extended period of time. Used to be 30 years, right now they're going by about 5-year time spans. In other words, climate change includes changes in temperature, precipitation, wind patterns, and other effects that occur several decades or longer. So they try to take what happens in Kentucky in September over a 30-year period, or now shorter, and say these are the average atmospheric temperature weather conditions in Kentucky in September. And that informs all of us, but especially like for farming communities, people need to know when to plant, people need to know when they can harvest. All of that has changed. Leah, you can probably speak more to this. All of this has changed over the last 10, 15 years. People aren't really sure when harvest is going to be or when a good time to plant is, mainly because of a lot more rain in the springtime. So what is causing climate change? We know what it is, now what's causing it? Essentially, it is an imbalance of the energy in our atmosphere. I know this is probably really hard for you all to see. On the left-hand side, we have what's called the natural greenhouse effect. The greenhouse effect itself is a really good thing. Without the greenhouse effect, we would not be here. The species that inhabit the planet would have no chance of survival because the planet would be too cold. Natural greenhouse effect is good. Human-induced greenhouse effect, or human-enhanced, If you notice this red band here, it says greenhouse gases. What we have done is we've made that blanket over the earth thicker. So if you picture, last night it was really cold at my house, I had to put 2 blankets on myself. When you put that blanket on yourself, where does the heat go? Oh, perfect. The blanket traps in the heat, right?
Yeah.
So it's the exact same thing with a layer of greenhouse gases. The thicker the layer of greenhouse gas, the more heat that cannot re-radiate back out into space. So it comes through in both the natural and the human-enhanced cycle. Solar radiation comes through our atmosphere, and you'll see a yellow arrow up there. A lot of it is able to escape back into space. The thicker the blanket, the less heat is able to re-radiate back out into space, and so we have this kind of bouncing effect. Carbon dioxide is, I'm sure you all hear about CO2 much more frequently than you do any of the other greenhouse gases, and there's 2 reasons for that. Number 1, CO2 is the most abundant greenhouse gas, and number 2, it lasts a lot longer in our atmosphere. So things like methane gas tend to break down over a period of about 15 years. Carbon dioxide can take hundreds, if not thousands of years to finally dissipate in the atmosphere. So the concern is how much CO2 we're putting out, the amount, as well as how long that's staying in our atmosphere and trapping heat back in. So how do we know what we know, right? We had the little skit where folks were saying, well, my family says this, and my teacher says that, and it's all very confusing. One argument that you'll hear, climate change can't be happening because we've always had these cycles. And that's absolutely true. The Earth has always had kind of this cyclical nature. When you look at CO2, this graph, all it's showing you is the concentration of carbon dioxide in our atmosphere. And you'll see in cycles of just about 50,000 years, the concentration of CO2 in our atmosphere has historically fluctuated. When it fluctuates up, it typically fluctuates back up to around 300 parts per million. However, this is 1950, and up here, that says current level. This graph is about 5 years old. The current level on this graph is about 390. The current level as of Tuesday, when I put this presentation together, was 403 parts per million of carbon dioxide. So in May of 2015, it was the first time carbon concentration had risen above 400 parts per million. And it teeters depending on the time of year, right? When plants are growing, plants absorb carbon dioxide through photosynthesis. So there's less in the atmosphere in certain times of the year. But we are above 400 at this point. One source of evidence that is used when you look at, is it us or is it a natural cycle? All of these lines, and I apologize again for the folks in the back, the top line is human population increase over time from the year 1000 to the year 2000. The next one down is a curve that shows carbon dioxide. The next one is nitrous oxide. The next one is methane. And then this is a curve of temperature change, average temperature. So what scientists have been able to show is that there's a fluctuation. There's a fluctuation, but then it just goes straight up exponentially. All of those different factors. They know this because CO2 gets trapped in a lot of different places, right? It's been stored underground in fossil fuels for millions and millions of years. We've taken those fossil fuels out of the ground, we've started to burn them, and we're re-releasing that CO2 into the atmosphere. Scientists have been able to dig dozens of miles below the Earth's surface and pull out ice core samples, and in those ice cores are tiny bubbles. And those bubbles have been frozen for hundreds of thousands of years, and they still hold the same concentrations of what was in our atmosphere 400,000, 300,000, 100,000 years ago. So scientists are able to look in those ice core bubbles and say, this is what was in the atmosphere so many years ago. They're able to look at river deltas, they're able to look at sediments in deserts. There are many, many different sources in our Earth's, what I call the natural history archive of the Earth, that scientists can extract this information from. Another thing that's important to talk about is this question of, well, how long have we been talking about it? Most of us think this is just a thing that came up in the 80s and 90s. Really, scientists have been talking about climate change since the early 1800s. There was a French physicist in 1824 who first described the greenhouse effect. There was an Irish physicist in the 1860s who identified the gases that caused the greenhouse effect. In 1896, there was a chemist that said that burning coal would increase CO2 concentrations in our atmosphere. In 1917, you all know Alexander Graham Bell as the inventor of the telephone, but he also had a lot of papers on natural resource conservation. And one of the things that he wrote about was the Earth becoming a sort of hothouse due to CO2 being trapped in the atmosphere. In the 30s, there was a scientist named Holbert who found an increase in CO2 levels that would increase in CO2 levels would increase global average temperatures. I couldn't find a picture of him, but this is actually a newspaper clipping from the 1930s, ironically enough, talking about how CO2 heats the planet. So, long story short, scientists have known about this for a really, really, really long time. We're going on, almost 200 years that scientists have been talking about CO2, the impacts of burning fossil fuels, and what that could lead to as far as a changing climate. Lastly, it's really important when you're talking about climate change to talk locally. A lot of times we talk about things that are on the other side of the planet. People, unfortunately, you all care because you're here, but a lot of people just don't care. If they don't see how it's going to impact them personally, it's not a concern. So local projections for Indiana, Ohio, and Kentucky. A lot of people think that we're in the southeast. We're not. When you're talking about weather, when you're talking about patterns, when you're talking about projections for climate change, Kentucky's projections are not that we're going to have a drought. We're not going to all of a sudden not have any water. We're actually going to have the opposite effect. So we're looking at a temperature increase of about 3 degrees Fahrenheit over the next potentially 60 years. We're looking at an increase in winter precipitation of 10%, which I love snow, so I kind of like that one. Spring and fall precipitation up 20% and summer up 30%. Our farming community, and whether we're farmers or not, we all eat. And so it is important to kind of think about the implications on our food systems, how that's going to have to change based on so much more water in every single season. Frequent extreme heat events in the summer, increase in frequency and severity of thunderstorms, tornadic storms, greater incidence of heat-related illness and death, expanded habitat and infectivity of disease-carrying insects. How many of you 30 years ago knew somebody that had Lyme disease? How many of you knew somebody within the last 5 years that had Lyme disease? There you go. My mother was in the hospital for 2 weeks this summer. She got bit by a tick and she contracted something called ehrlichiosis. She couldn't eat for 2 weeks. She almost died from a tick bite. So I personally have seen how something like this can lead to direct impacts on all of the people that we love. Increased water runoff. You all know Kentucky is famous for flooding, and we're just going to have more of that. Again, how does that impact our farms, transportation, safety? If you live sort of in areas where you're up on a hill, that can get really dangerous, and it is dangerous, and we see stories about it in the news every day. Landslides, erosion, levels of pesticides and fertilizers with more runoff. A lot of what we put on the soil on our farms is running off into our waterways, which is a whole nother talk show and a whole nother ball of wax as far as what impacts that could have on our sources of water. And lastly, more invasive species.